Hi, this is Jude Leonard, Assistant Professor from PG and Research Department of Physics, St.Joseph College of Arts and Science, Cuddalore. Today we are going to discuss about the fundamental of nuclear models. First, we have to see nuclear force and its properties. We know that nuclear force is the strongest force when comparing to gravitational force and electrostatic forces. It is 1038 times stronger than the gravitational force and 1 or 2 times greater than the electrostatic force. And the another two weak forces, it is quite stronger than 1013 times of it. And nuclear force is considered as one of the strongest forces in the nature. And even though it is the strongest force in nature, it has a very short range. It is almost a Fermi. They operate within the nucleus and the distance is almost a Fermi. The nuclear force does not depend on the charge of the nucleon. The force doesn't depend upon the charge of a proton and a neutron, whereas there are basically attractive forces. The distance between the nucleons is less than 0.5 Fermi, that is half Fermi, and nuclear force becomes repulsive. If it is less than 0.5 Fermi, the nuclear force becomes repulsive. And it is a non-central forces and they are also non-conductive forces. Nuclear models, there are a number of nuclear models, right from Bohr's model. It can refine by one, and nuclear models defines how it is, how the nucleus is is situated, how it is the structure has been defined. Nucleus is a complicating structure to understand, and there are three fundamental basic which describes the structure of the nucleus. One is liquid drop model, fundamental model, the next one is shell, and the other one is collective model. The theoretical models of the nucleus treats the problems of two divergent perspectives. It sees how the structure of the nucleus in different perspectives. At macroscopic extreme, it is a liquid drop model. The model, that is the structure of the nucleus, is compared to a liquid drop, which examines the properties of a nucleus, such as energetics, binding energy, size, shapes, and the nucleon distribution inside the nucleus. This model assumes that nucleons are alike other than the charge. They are alike. It is considered as the alike. It resembles the drop of a liquid, and the properties of a liquid is similar and comparative to the nuclear structure. Whereas in contrast with that, the shell model is designed to account the quantum properties of nucleus, such as it details about the quantum mechanical properties of the nucleus, called as spin, quantum states, magnetic moments, and magic numbers. The assumption of the shell model is that nucleons are different. The fundamental idea behind the shell model is the nucleons are different. That is, the nucleons are fermions. Thus may occupy different quantum state as in the case of atoms. Since it is treated in quantum mechanical factors like quantum states, spins, magnetic moments, etc., and which details about the micro and quantum structure of the nucleus. And liquid drop model, this is introduced by Niels Bohr, and on the aggregate of nucleus have the same properties, and when comparing to the liquid drop, the properties are surface tension, cohesion, and deformation structures. The model assumption in terms of volume, the volume of the nucleus is directly proportional to the total number of nucleons present in it. Since the number of nucleons is high, if it is high, the volume should be more, obviously. The volume of the drop is always proportional to the total number of atoms or nucleus contained in it. It is a density. It is also called as density. The volume of a drop is proportional. If the density is high, the volume also keeps on high. It is nearly a constant, so that of a liquid drop. It is in terms of binding energy. The binding energy of a nucleus increases with the increase of number of nucleons. If the nucleons is high, that is the number of protons and neutrons is more, it means the binding energy, the chemical binding energy, which is high, which keeps the proton and neutron inside the nucleus, almost 1 Fermi. And in analogous, the cohesive force on the surface tension within the liquid drop. The liquid drop is considered as the overall surface the force existing on the surface as the surface tension. Cohesive force in terms of a liquid drop. Similar to that, nuclear structure also has a surface tension, and it makes the nucleus in spherical in shape as in the form of a liquid drop. If the nuclear tension on the surface of the nucleus is responsible for the spherical in shape, similarly the nuclear force has the same kind of spherical in shape. It is considered as spherical in shape. Very large drops of liquid are not stable for long, and it is comparatively liquid is not strong, not stable enough, since the force of the surface tension progressively becomes weak. If it is not strong, it is obvious the structure, that is the surface, is similarly weak. The surface tension is weak, and the large drop dissociate into smaller drops, and it is nuclear fission. Similar to that, when a large drop is divided into smaller drops, similar to that, when a nucleus is gets breaked up into smaller pieces. In the case of atomic nuclei, the size of the nuclei increases with the mass number, and for heavy metals, as you know, the size of the nuclei reaches a critical value and gets deformed. The next step, when it reaches the critical with that more number of protons and neutrons, it gets deformed. And what are the advantage and disadvantage of liquid drop model is, the liquid drop model examines the macroscopic properties such as energetics, nuclei, binding energy, shape, size, and distribution of the protons and neutrons inside the nucleus. It deals with the macroscopic properties. The binding energy equation derives by this model. The binding energy, in other terms it is called as Weizsäcker's formula or semi-empirical mass formula. The nuclear binding energy is a function of mass number and protons. The binding energy depends upon the mass of the protons and the neutrons, or the number of protons and neutrons. And the disadvantages, it doesn't give the idea about the magic number, where shell model defines the idea of magic number, and this particular model doesn't explains the concept of magic number. And similarly, the microscopic properties, the quantum mechanical properties, can't explain in this particular model. And shell model, the next advanced model is comparatively from liquid drop model. It is a shell model. It is a atomic model where electrons arrange themselves into shells. So the concept behind the shell model is a closed type of shell. The nuclear structure is considered as a closed structured shells, and assumptions are the nucleus arranged in different energy levels within the nucleus. In the form of shells, these shells have different energy levels, and the nucleons are arranged according to their energy levels in the shells. There are two sets of energy shells in the nucleus, one for the occupation of neutrons and the for the protons. There are two sets of energy shells, one for proton and one for neutron, and each energy level is occupied by two protons and neutrons, provided the spins are opposite. One is parallel and one is anti-parallel for both protons and neutrons. The spins are opposite direction. The magnetic field of each cancel out each other. Then since the spin is opposite in nature, the magnetic field of both these two gets opposite in direction and cancel out each other, and this is responsible for the stability of the nucleus as far as the shell model is concerned. And the advantages is, the model has been very successful explaining all the fundamental basic properties there is of nucleus, such as angular momentum, magnetic moment, etc., shape, size, and these fundamental nuclear properties of a nucleus is completely explained by the shell model, and especially the magic number. And the existence of magic number is predominantly explained in this shell model, which clearly explains about the nuclear stability of the nucleus, and it explains the relationship between the protons and the neutrons and the nuclear stability. How much the nuclear stability is dependent upon the number of protons and the number of neutrons. And the final one is the collective model. As the collective model is the combination of both the liquid drop model and the shell model. It explains both the macroscopic and the microscopic properties which came from the liquid drop model and shell model. The nuclear force, there are neutrons and protons in the nucleus. These particles are binded together to form a strong nuclear force. The ideas of both the shell model and liquid drop model are collectively given in a separate model called as collective model, and it explains the neutrons and protons have a strong nuclear force inside the nucleus, and the force existing between the neutron and neutron, neutron proton and proton proton, and these are called as nuclear force, which is responsible for the stability of the nucleus. The idea is from the shell model, and the protons and neutrons, the number of protons and neutrons are responsible for the stability of the nucleus. It means that the nuclear force was attractive by nature. It is quite attractive. Thank you.